Okay, so we're starting out with our same two toroids, but on this one I put a different output coil. So this has 40 turns of smaller wire, and this has only 30 turns of larger wire. So we're starting off here at 12.09 volts, and I'm going to turn it on. So you can see that this one on the right is doing a little bit better than the other one. Now the inductance is different between this coil and that coil, so I had to put different capacitors on here. And I'm going to show you that. So this coil here has a lower inductance, 5.99 millihenries, and it has a lower frequency, 3.9 milliseconds between pulses, 256 hertz. So with that, I calculated the capacitors to be 64.32 microfarads. And now this one over here, it has higher inductance. This has a 6.92 millihenries, 1.5 millisecond pulses, and the capacitors are calculated at 8.2 microfarads. We're going to take a look at the input. This one has higher voltage, so I dropped down the current. That's 2.5 amps, 7.9 volts. And this one has 3 amps at 6.7 volts. So I've calculated it out here. 2.5 amps times 7.9 volts equals 19.75 watts. 3 amps times 6.7 volts equals 20.1 watts. So this one is actually using a little bit more, but it's not climbing as fast as this one. So the reason is because this has a higher voltage, but this has more current, and that current is going to push this battery up much faster.